When selecting MTW insulation for a 24 volts direct current power supply, it is crucial to adhere to the National Electrical Code, specifically Article 300.3, Seat 1. This section mandates that the voltage rating of the conductor's insulation must be at least equal to the voltage of the circuit. In your situation, with a 24 volts direct current power supply, the insulation must be rated for a minimum of 24 volts. While MTW insulation rated for 300 volts might appear to meet this minimum requirement on paper, opting for MTW insulation with a 600 volts rating is the strongly recommended approach. There are several reasons why using 600 volts MTW insulation is preferable. Firstly, it offers a significantly higher safety margin. Although your circuit operates at 24 volts direct current, the higher insulation rating provides an added layer of protection against potential voltage spikes, surges, or any unforeseen overvoltage conditions that could occur within the system. This enhanced protection minimizes the risk of insulation breakdown, short circuits, and potential electrical hazards. Secondly, 600 volts MTW insulation is the industry standard for most commercial and industrial electrical installations. It is a widely recognized and readily available option, ensuring compatibility with other components and wiring practices within your overall electrical system. Using a standard insulation rating simplifies installation, maintenance, and future upgrades or modifications to the system. Thirdly, 600 volts MTW insulation typically has a more robust construction and is designed to withstand harsher environmental conditions compared to low voltage rated insulation. It is generally more resistant to abrasion, chemicals, moisture, and temperature extremes, making it a more durable and reliable choice for long-term performance, especially in demanding industrial environments. Fourthly, consider the potential for future expansion or modifications to your electrical system. If there is a possibility of increasing the voltage of the circuit or adding new components with higher voltage requirements, using 600 volts MTW insulation from the outset provides the necessary headroom to accommodate these future changes without needing to rewire the entire system. This can save significant time and expense in the long run. Fifthly, adhering to established industry best practices and recommendations helps ensure compliance with safety regulations and promotes a higher level of overall electrical safety. Electrical inspectors and regulatory bodies typically prefer or even require the use of 600 volts MTW insulation in commercial and industrial applications due to its superior safety characteristics. Using the appropriate insulation not only protects your equipment and personnel, but also demonstrates a commitment to responsible electrical practices. To summarize, while 300 volts MTW insulation might technically meet the bare minimum voltage requirement for a 24 volts direct current power supply, it is not the recommended choice. Opting for 600 volts MTW insulation offers numerous advantages, including a higher safety margin, adherence to industry standards, improved durability, allowance for future expansion, and enhanced compliance with safety regulations. By selecting 600 volts MTW insulation, you are investing in a more robust, reliable, and safe electrical system that will provide long-term performance and peace of mind. When making your selection, be sure to consult the specific requirements and guidelines outlined in the National Electrical Code and any applicable local electrical codes or regulations. Always prioritize safety and choose the insulation that provides the highest level of protection for your application. For clarity, let's break down some key aspects regarding the selection of MTW insulation. Firstly, understanding the role of insulation is paramount. Insulation serves as a protective barrier around electrical conductors, preventing unintended electrical current flow. It confines the current to the intended path, minimizing the risk of short circuits, electrical shocks, and fires. The voltage rating of the insulation indicates the maximum voltage that the insulation can safely withstand without breaking down. Secondly, the National Electrical Code, or NEC, is a comprehensive set of standards and guidelines for safe electrical installations. It is widely adopted and enforced in the United States and many other countries. Article 300.3 C1 of the NEC specifically addresses the voltage rating requirements for conductors. It mandates that the insulation voltage rating must be at least equal to the voltage of the circuit. This requirement is in place to ensure that the insulation can effectively prevent electrical breakdown under normal operating conditions. Thirdly, MTW stands for machine tool wire. It is a type of single conductor wire commonly used in industrial and machine tool applications. MTW wire is typically insulated with polyvinyl chloride, or PVC, which provides good resistance to abrasion chemicals and moisture. It is available in various voltage ratings, including 300 volts and 600 volts. Fourthly, the term 24 volts direct current, or 24 volts direct current, refers to a low voltage power supply commonly used in control systems, automation equipment, and other electronic devices. Direct current means that the electrical current flows in one direction only, as opposed to alternating current, or AC, where the current changes direction periodically. Fifthly, let's consider the concept of safety margin. In engineering design, a safety margin is an extra capacity or strength that is built into a system to account for uncertainties, variations, or unexpected events. In the context of electrical insulation, a high voltage rating provides a greater safety margin, reducing the risk of insulation breakdown due to voltage spikes or surges. Sixthly, industry standards and best practices play a crucial role in ensuring safe and reliable electrical installations. Adhering to established standards, such as those outlined in the NEC, helps promote consistency, compatibility, and interoperability among different components and systems. It also simplifies installation, maintenance, and troubleshooting. Seventhly, environmental factors can significantly impact the performance and lifespan of electrical insulation. Exposure to extreme temperatures, humidity, chemicals, and abrasion can accelerate the degradation of insulation materials, potentially leading to premature failure. Selecting insulation that is specifically designed to withstand the environmental conditions in your application is essential for long-term reliability. Eighthly, the potential for future expansion or modifications to your electrical system should be carefully considered when selecting insulation. If there is a possibility of increasing the voltage of the circuit or adding new components with higher voltage requirements, using insulation with a higher voltage rating from the outset can save significant time and expense in the long run. Ninthly, compliance with electrical codes and regulations is mandatory in most jurisdictions. Electrical inspectors and regulatory bodies typically enforce the requirements of the NEC and other applicable codes to ensure safe electrical installations. Failure to comply with these regulations can result in fines, penalties, and even legal action. Tenthly, ultimately, the selection of MTW insulation should be based on a comprehensive assessment of your specific application requirements, taking into account factors such as voltage, current, environmental conditions, industry standards, and future expansion possibilities. Always consult with a qualified electrician or electrical engineer to ensure that you are selecting the appropriate insulation for your needs. Furthermore, it's important to understand the potential consequences of using inadequate insulation. If the insulation voltage rating is too low, the insulation may break down under normal operating conditions, leading to a short circuit. A short circuit can cause a surge of current that can damage equipment, start a fire, or even cause electrical shock. Using the correct insulation is therefore essential for protecting your equipment, your property, and your personnel. When selecting MTW insulation, you should also consider the wire gauge. The wire gauge determines the current carrying capacity of the wire. The higher the current, the larger the wire gauge that is required. The NEC provides tables that specify the allowable ampacities for different wire gauges and insulation types. You should consult these tables to ensure that you are using the correct wire gauge for your application. In addition to the voltage rating and wire gauge, you should also consider the temperature rating of the insulation. The temperature rating indicates the maximum temperature that the insulation can withstand without degrading. If the wire is exposed to high temperatures, you should use insulation with a higher temperature rating. The NEC also provides tables that specify the allowable temperature ratings for different insulation types. It is also good practice to label your wires and cables clearly. This makes it easier to identify the wires and cables in the future, which can be helpful for troubleshooting and maintenance. You can use wire markers or cable ties to label your wires and cables. Also, it is important to inspect your wires and cables regularly for damage. If you find any damaged wires or cables, you should replace them immediately. Damaged wires and cables can pose a safety hazard. Here are some additional points to consider. Firstly, consider the specific application. Is it a dry or wet location? Is it exposed to chemicals or abrasion? The answers to these questions will help you determine the appropriate type of MTW insulation to use. Secondly, refer to the manufacturer's specifications. The manufacturer's specifications will provide detailed information about the voltage rating, temperature rating, and other characteristics of the MTW insulation. Thirdly, consult with a qualified electrician. A qualified electrician can help you select the appropriate MTW insulation for your application and ensure that it is installed correctly. Fourthly, always energize the circuit before working on it. This is the most important safety precaution you can take when working with electricity. Fifthly, use the proper tools. Use the proper tools for stripping and crimping wires. Using the wrong tools can damage the insulation and create a safety hazard. Sixthly, make sure the connections are tight. Loose connections can cause overheating and arcing, which can lead to fires. Seventhly, test the circuit after you have completed the work. This will ensure that the circuit is working properly and that there are no shorts or grounds. By following these guidelines, you can ensure that you are selecting and installing MTW insulation safely and effectively. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or electrical engineer before making any electrical installations or modifications. Using 600 volts MTW insulation for 24 volts direct current power supply offers a robust and safe solution. While the 300 volts option might seem adequate, the added protection and industry standard compliance of the 600 volts insulation make it the superior choice for most applications. Remember to always consult the NEC and local codes, and when in doubt, seek advice from a qualified professional.